In your textbook, they gave you the graph of y equals the square root of x already. Of course, if this was a test question, you wouldn't have to have this because you know this graph already. You already know the square root graph. You know that it has 0, 0, 4, 2, 1, 1. Those are key points on your graph. We want to graph y minus 2. So first of all, I'm going to take the time to move that 2 over to the other side, because that 2 is going to move things up and down. What does the negative do? Which kind of reflection? Vertical or horizontal? Vertical, because it's outside. The 3 there, that's going to multiply x by 1/3, right? It's going to be a horizontal compression. Okay? What about that 3? Translation, horizontal translation, which direction? It's going to move left, and how many? 3. Wrong. Close, but wrong. Why? We have to factor. This is the special note. Gavin made the thing on his phone to send him a message at 10 p.m. That's why he's remembering. Because we have a horizontal compression and a horizontal translation, before we do anything, we have to write it in factored form. In other words, we have to factor the 3 out, leaving us with x plus 1. So yes, it is a horizontal translation. Yes, it goes to the left, but it only goes 1 to the left, not 3 to the left. And that's what makes this, that's why I said if you set a message on your phone every night, it's hard to see. It's easy to overlook. And then I moved the 2 over so there would be a plus 2. So if we're labeling things here, we have a vertical reflection that will multiply your y values by -1. A horizontal compression, x is getting multiplied by 1/3. Horizontal translation, 1 to the left. And a vertical translation, 2 units up. The way we've set things up for doing our new graphs is we take points from our original graph, and we've got some labeled here. I'm going to take 0, 0. I'm going to take 1, 1. I'm going to skip 4, 2. And I want you to try and figure out why I prefer the next one, 9, 3. Then we draw. Stretches and compressions will happen first, and then translations afterwards. So when I go to write things above my first set of arrows, stretches, reflections, compressions, so basically every time you're multiplying goes in this first set of transformations. So I'll write y by -1, x by 1/3, and then translations after. So here I'm going to write 1 to the left and 2 up. So now I can start filling that in. Oh, multiplying by 0, 0 by things. Well, this stays 0, 0. The next one, multiply y by -1, -1, x by 1/3. 1 times 1/3 is 1/3. So at this point, you're like, ooh, a fraction. It's not bad. It just means that it's going to be a little bit trickier to graph, but it's not bad. So if you chose a point that gave you a fraction, it's not bad. Can you see why I chose 9, 3? Because when I multiply my x by 1/3, it stays a nice number. And y by -1. Next, we need to move things 1 to the left -1 and 2 up. If you're at 1/3 and you move 1 to the left, where do you go? -2/3. Again, the fraction is just a little bit more tedious working with the math. How do I subtract, right? We got to remember, how do I subtract fractions? I need a common denominator. That would get me -2/3. And -1, move that 2 up, will be +1. Back to whole numbers again, things are good. 1 to the left, 2 up, -1. Now that we have our new points, we can draw those points. So I've got -1, -2, -2/3, -1. So here I'm just going to estimate where -2/3 is, -1. And finally 2, -1. Again, when thinking about what is the shape going to be, I might say to myself, what was my original point? That's this key point where the graph started is 0, 0. What happened to 0, 0? It changed to -1, 2. This is my starting point here. So my graph has to look like this. Still has the same kind of curve as my original graph. If we think about what we wrote down at the beginning, vertical reflection, that would flip it down. Does it look like it's been flipped down? Yes. Horizontal compression by 1/3, squished in. It's a little bit hard sometimes to see squished in or stretched out. But has it been moved 1 to the left and 2 up? It appears to have that done as well. So our shape looks like the right kind of shape. It's good I zoomed out because it allows me to reread the question. What are the domain and range of just the blue one? Now that we've graphed it, while our domain are our x values, I'll use interval notation. The smallest value is -1, but it goes up forever. So I can say -1 to infinity. That's like saying x is bigger than or equal to -1. And my range, there is no smallest value because that arrow says that it keeps going to the right but also keeps going down. So it would start at -infinity, but it does have a maximum value at 2. Square bracket on 2 because that value is included. That's the same as saying y is less than or equal to 2. All right, try questions 8 and 10.